I'd like to turn to our featured modeler, John Bate. John is going to talk to us about a subject that I personally have been really interested in and know nothing about. And that's why I'm so happy that he agreed to do this for us tonight. The NMRA started a new program called the LCC. And now you have the extent of my knowledge on that program. So John, I will turn it over to you. Thank you so much for doing this.
Well, you're very welcome. And I'm not going to spend too much time as a talking head here. I'll be sharing a whole lot of screens as I go through this. This is going to be a very high-level sort of introduction, and the prerequisite for this particular course is that you know nothing about LCC. So we'll get started by just giving you an idea of just what this thing happens to be. What it is, in a nutshell, a system for controlling anything except a train. So DCC was intended originally to be used to control trains, and it's still meant for that. It's been used now to control different things with accessory decoders, but that's a little limited. You can throw a turnout with your throttle with it. If anybody actually ever does that, I don't know, seems to be a little silly to me. But to do all the other things, particularly if you get up into signals and things like that, and block detectors and controlling your room lights and the lighting on your layout and all sorts of things. Layout command control started about 10 years ago, actually. And that's for controlling everything else. So anything electronic that you can imagine that produces or consumes mostly a 5-volt logic signal, or even more complicated things like servos, LCC can do that. And let's just do an example. So here I've got a little 3-track yard. I want it remotely controlled somehow or with a front panel, so I'll throw in some switch machines for them. And I want to control that. And then in order to do that, well, maybe I want 3 push buttons or switches to select track 1, track 2, track 3. And these have to control 4 turnout machines with 3 switches. So you need traditionally something called a diode matrix. So you need some kind of circuitry in there to control that. And you're getting a few wires on your layout. Then I decide, well, I want indicators as to where the trains are, which tracks are occupied, whether something's coming from the east or whether something's coming from the west. So I'll throw in 5 block detectors here. Those are little NCE block detectors I've shown there, but there are many different kinds. And I want those to light up LEDs on my front panel down at the bottom, my fascia. So I'm going to throw those in, put some wires to connect those. And then this is working really well. So what the heck, let's throw in a signaling system. So we've got some signal towers. Those are little N-scale cheap signal towers from Digitrax, those ones actually are. And okay, those look good, but we need, maybe a dispatcher or something. So you throw in NMRA on a computer, which can do anything up to a CTC control panel for a dispatcher. And of course, you need an interface now to hook it up to the computer, and you need a computer at your layout at all times to run this thing. And pretty soon you're getting pretty complicated with a lot of wires running around, and those are just very abstract wires on the screen there. You would actually need a lot more than what I've shown there. And you wind up looking something like this. And that's the underside of a yard throat and fully signaled and with every toy in the book on it on one end of my layout. And I'm going to throw that away because it's too painful to look at anyway. So LCC, what would it do? Well, with LCC, the idea is you keep the majority anyway of the wiring local. So you would have the gadgets at one end of this yard maybe hooked up to one LCC node. Another node at the other end with the things at that end hooked up to it. Maybe a third one. Certainly the fascia panel at the front, all of its switches and lights would be hooked up to a node there. And so you make it look a little cleaner like this. And to make all of what normally would have been dozens and dozens and dozens of connections between all of these things, you don't have a great big bundle of wires. You just have a little Cat5 cable. Cat5 cables, those are the things that you normally think of as internet cables. They're used to plug computers into wired internet ports, if anybody actually uses wired internet these days anymore. And there's actually only 8 wires in that cable, and 2 of them aren't used, and 2 of them are used for power. So only half of those 8 are actually used to make connections between all this stuff. So how the heck do you use 4 wires to connect dozens and dozens and dozens of things? Well, the idea is that you do it with events, and I'll show you exactly what an event looks like and how it works and how you to set them up and everything in a minute. These nodes, of course, like decoders in locomotives, like CTC panels, like your DCC system itself, your command station, they're all really computers. So all those LCC nodes are little wee computers, the same as you would get in an Arduino or something like that. They can be pretty smart. They can figure out a signaling system all by themselves without a computer involved. They can figure out the most complicated routing sort of algorithms you want. They could pretty much control this stuff in any reasonable way that a model railroader would ever want to control them. You can run this thing so that it powers up and it's there and it's running, no computer involved. Sort of. I will explain the sort of at the end. So what happens here? Well, what happens when one of these buttons gets pushed is it's connected to an LCC node with one of its pins, one of its input and output pins. And the LCC node watches for that and says, oh, hey, something just changed on pin 5 or something. A button was pushed, a train showed up, a turnout was thrown, something. And you can say, oh, when you see that happen, tell everybody about it, generate an event. So there's an event. This LCC node just produced that event. So we talk about producers and consumers. Any node can produce an event anytime it wants in response to anything that happens. And so this LCC node just produced an event, and you usually see events, they look like that. They look like 8-digit hexadecimal things. And unfortunately, in the NMRA magazine, some of the articles about this started off by explaining all that and what all that hexadecimal stuff is. Forget it. You do not need to understand that thing. You just need to know that there is this magical, incomprehensible thing that means somebody hit that switch. And at the other end of things, that message goes out to everyone. It goes out to the entire network, right down to those little tiny squares at the ends. Those are terminators. You need a terminator at each end to shut off the network at the 2 ends. The network has to be linear, always just a straight line, no branches, one line. And everybody sees that. And now what you can do is you can tell whatever node you want, multiple nodes, to do something when it sees that. So the LCC node on the left end there says, oh, when I see that particular event, I'm supposed to change these turnouts in a certain way, make that one straight through and make that one diverging or something. That LCC node is now called the consumer of this event. It's taking that event and doing something about it. Anybody can consume an event. Multiple nodes can consume events. The same node that sent it can consume an event. Anybody. The node at the other end sees exactly the same event at exactly the same time and responds by saying, whoa, that's for me too. I have to throw a couple of switch machines, and presto, the job gets done. And so that's events. Why you can get what amounts to dozens, hundreds, thousands of electrical connections through these 4 wires is that this is a computer network, and all you have to do is say, oh, if there had been this wire here, it would have changed. It would have changed from 0 to 1 or 0 volts to 5 volts or high to low or something. And the thing you have to always keep in mind with this is to simulate 1 wire, you need 2 events. One to say when it changed in one direction, and then another event to say it changed in the other direction. So when a switch goes up, you'll generate an event, as happened here. When the switch goes down, it has to generate a different event to tell everybody, hey, that switch is down now. And so you normally, not always, I'll give you an example of not always, you normally have them in pairs, one each way. But you can send a semi-infinite number of different events along this thing to simulate and to control more wires than the largest layout in the universe would ever need. It's enormous. So that's what an event is, how it works. There is a little caveat though. I had a little bracket almost or something in a slide back then. And that is you have to teach these nodes what to do. That node in the middle has to be told, oh, when the switch connected to pin 5 gets thrown, send that event that's shown on the screen there. The other nodes at the ends have to be told when you see that event, throw this switch this way and throw that switch that way. You have to configure these things. It's not programming as such. There's no programming language involved here, but you have to tell each one what to do when you get an event and when you want to produce an event. It's infinitely flexible, and that system is a great start because you can do anything with it. You can literally do just about anything with just this simple event producer consumer model.
John,
yes.
can I ask you a question here?
Sure.
When I am giving instructions for things to do this event or stop or do the other event, what am I doing it on? Am I doing that on my computer? What am I doing all of this on?
Well, I'm glad you asked that because that is the next slide.
Oh, okay.
What you do, of course, is you need to use a computer to set this stuff up. So there is a computer that you hook on via USB. So the gadget is usually called a USB buffer. And you hook that onto your computer, and then you use your computer to program all of these nodes to do the right things. Once you've programmed them, you can take that computer and that buffer away, and all those nodes will still remember what to do. And you don't need a computer in place to actually run your layout. But to set the stuff up, well, you do. Theoretically, there's a way to do it without a computer, but it's such that it's totally impractical and nobody could ever possibly do it without a computer.
John, let me ask another dumb question.
Sure.
How computer literate do I have to be in order to operate this on my computer?
Well, I will show you exactly that. I will actually demonstrate what you need to do. And then once I've shown you how you do it,
gotcha.
You can decide for yourself whether you think you could do that or whether you can't.
Gotcha, thank you.
John, before you jump into where the computer comes, I notice you still have toggle switches on your control panel. When we are done, will our operators who are comfortable only with the toggle switch be able to select a track in the yard with just that toggle switch?
Well, though I've shown toggle switches there, of course, those would really be push buttons, not toggle switches.
They can be push buttons or something. Yeah. A manual input from a finger is very helpful for those that are not as computer literate as we would like.
Yeah. Well, that's exactly what this would be. You would walk up to this railroad and you would see a fascia and it would have a little diagram of your yard on it with a push button on each track, and you push a button and you get that track.
Right answer. Thank you.
You would set it up to do exactly that. Okay?
Yep.
All right, let's just forget that now. And I'm going to switch to a different share and actually show you one of these things. So there is an LCC network. And there's actually 2 nodes on there. There are 3 boxes, but there's only 2 nodes. And I'll just show you what they are. The one on this end, that's just a power supply. That's supplying power to the network. The blue cables, of course, you probably recognize the ends of these things, and the color blue that is used there, those are just normal computer cables. They have to be, for some bizarre electrical reason, at least 1 foot long. They can be very, very long, but they can't be less than a foot for some reason. This one in the middle, that's what an LCC node looks like. So this one happens to be a signal LCC by RR Circuits. And this little connector right there that I hopefully can point out, that contains 8 general purpose input-output pins. You can use them as inputs, outputs, whatever you want. They're digital logic, 5 volts, 0 volts sorts of outputs. You can get things that plug into them that control more complicated things like relays and servos and stuff like that that requires a little bit of guts and a little bit of power. But they can control 8 things, 8 lines. This particular one is set up for a signaling system, and that's probably the sort of thing you would want LCC in order to be able to do, is it really comes into its own when you get up to a layout that is complicated enough that it is in the signaling sort of category, even if it doesn't have signals on. These 2 little connectors on the sides, they would drive 16 LEDs and in signal towers, presumably. And it has some fancy stuff for setting up signals, and it's meant for controlling signals. I won't use those. I'll just concentrate on these 8 general purpose ones back here. And the third thing is this guy. That's my computer interface. And so we have just an ordinary USB cable here running off to the computer. And on the other side, we just have a wall wart powering the thing. But there's your things that are going to be in your layout, just like that. Okay, so that's what it looks like. You can get these things from RR Circuits. Oh, there's the name of them right there. To set this up and try it if you want to, you would buy one node. They have several different kinds. And all of the rest of this stuff comes as a starter kit, including these 2 little guys at the ends, which look sort of like memory sticks, thumb drives, USB drives, whatever you want to call them. And those are the terminators. They just plug in place of a cable, one at each end. So that's what it looks like. How you control the silly thing. Okay, so how would you program that thing? Right now, I've set it back to just as it comes out of the box. It doesn't know how to do anything. And let me show you how you would program this thing. What you would do is use good old Panel Pro, part of JMRI. So JMRI, we've probably mostly heard of that, and use it for Decoder Pro. There's also Panel Pro. JMR is really more like a suite of programs rather than one program. And Panel Pro is the one that you would normally set up, CTC systems on or something like that. But in the middle of it, right there, is an OpenLCB or LCC menu. You might get one or the other depending on which version of JMRI you have. This one says OpenLCB, but if it says LCC, that's the same thing. It's not really the same thing. That's a whole political thing, but I won't get into that. Underneath that little menu, well, one very useful thing is a little thing called a traffic monitor that can show you what's happening on your LCC bus. Well, I guess I need something to actually generate events on my LCC bus. So let me introduce you right now to my layout. Here's my layout. For the purposes of this demonstration, I've got 2 switches, 4 lights, 4 LEDs. I've got a few current limiting resistors in there, but otherwise that's it. There's no circuitry on this thing. And I'm going to just use that as my sort of test bed. It's only switches and lights, and you say, well, I want it to control turnouts and I want it to control all this sort of thing. If you can get switches and lights to work, you can get anything else to work too. The principles are exactly the same. You control them exactly the same way. I'm just going to plug this thing into that socket right there. There's my railroad. Okay, let's take a look at what I was talking about just a second ago, the traffic monitor. If you bring that up, and I'm not going to talk about how you install JMRI and how you get Panel Pro, that would be another clinic or something. Here's the traffic monitor window that you would get. Looks blank right now, but I'm going to go over and flip those switches on that little test layout. I'm not going to show you that, but I'll just flick them. So there's switch 7. I just flicked it up, and there's switch 7. I flicked it down. Ignore most of that stuff. I'm going to be saying a lot of things that boil down to ignore that. That little thing at the end, there's the event that it produced when I did that. The LCC nodes typically come with everything automatically connected as an input and automatically generating two different events, one when the input goes high or 1 or 5 volts and another when it goes the opposite. And so I didn't do a darn thing to set this up. It just came out of the box this way. So there's the particular event for the one and the other. I want to tell you also to ignore most of that event. Just those 4 at the end, that's the real event. The rest of it identifies which node sent it. And normally that's kind of automatic. Each manufactured node by any manufacturer anywhere in the world at any time, it has a unique identifier in it. And the events normally have that unique identifier tacked onto the front. And then what you control is just these little bits at the end. So just look at the little bits at the end. That's all that's important. So 4E, 4F, that means the switch on the left went up, switch on the left went down. If I hit the other switch, it generates a 5A and a 5B. Okay, so there's my 2 switches. There's what they do. There's what events they produce. And I didn't do a darn thing to get them to do that. It was just automatic. Okay, let's go back to my Panel Pro again. All right, that's one thing that's under that menu. And the only other thing I need to show you is configure nodes, which, guess what, configures the nodes. That's how you get at them. So if you hit that configure nodes, what you will see is something that looks like this. Well, almost. Fair warning here, what you see on the screen right now is a new version that is not actually released to the public yet. It'll be much the same, except the formatting is a little different. These gray bars aren't there and so on. And you look at this thing and you scroll down 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 and you scroll down, and there'll be a whole lot more in a real one. And you think, oh, I'm never going to be able to handle this. First thing you do is get rid of all that stuff. So all these little down pointing arrows, just close up every single one that you see, get rid of it all until you're down to that. Okay, so it doesn't look quite so forbidding now. You really only need 2 of those things. And one is kind of handy at the top. Each node, each little LCC device can have a name. Give it a name. Call it, the Cranbrook East Yard or something like that. Whatever lets you know, well, where is this node? What's it controlling? It turned orange. Those of you who use Decoder Pro, and that's probably most of us, will recognize that as meaning, hey, you changed something, but I haven't written it to the device yet. I haven't actually put it in the locomotive decoder yet, or in this case, I haven't put it in the LCC node yet. And there's a little right button to do that. And there's another little button down here that says Save Changes. That will write all of them, all of the changes that you happen to make in there. And now that I've done that, I won't go over and do it, but in the list of those that you get, you can see actually, well, maybe I should go over there and show it to you.
Can I ask one quick question before you do that? So do all the LCC nodes as manufactured have a unique identifier then?
They do. It's a globally unique identifier. Each manufacturer, a piece of those 6 bytes is assigned to each manufacturer. Actually, every NMRA member has his or her own one. So if you're an NMRA member, you have a unique code that you can put on all of your stuff. There are many, many, many of these things, and they're globally unique. So, and this is really unlikely to happen in my opinion, but if you took a module with LCC stuff in it and went to a big modular layout and plugged it into everybody else's modules, your nodes are guaranteed not to produce the same events as anybody else because they're going to be globally unique. Okay, when you first open up, and I skipped this part, when you first open up your configure nodes thing, what it'll do is it'll give you this. It'll give you a little look at, here's your whole network, your whole LCC system. There's two things on it. What are they? Well, if I hit the little plus sign, this one says JMRI Panel Pro, excuse me. That's the computer interface. That counts as a node, and that's talking to JMRI right now, which I'm seeing and using. Here's the other one. Hey, look, it says Cranbrook East Yard, misspelled. That's what I just did. I just called it that. So if you have a whole bunch of nodes, you can easily name them, identify them, tell which one it is. And inside here, there's the configuration dialog, which is the other thing I just showed you. You can see it's on a circuit signal LCC. It's called the Cranbrook East Yard, a little bit of information, but it's this thing, the open configuration dialog, which opens the thing that I already showed you.
John, when you're doing that, if you generate a typo, which often happens, can you go back and change the name of the node if you blow it first time?
You can change anything at any time. Nothing is in write-only memory, as it were. Now,
okay.
Everything is configurable. I could go back and correct my R there and put it in lowercase. That wouldn't be a problem. It wouldn't even affect the events because the events are the same hex code no matter what it's named.
Thank you.
Good. So I named the node. The only other thing that you need, unless we get into conditionals later on, is here's the thing that allows you to control those 8 pins. So here we go. Here's the thing, and it's not too long. Line 1, 2, 3, 4, 5, 6, 7, 8 along the top. So this allows you to control what's going to happen with each of those 8 pins. Let's start with number 7. I happen to have connected that first switch up to pin 7. I didn't pay attention to what pins I was connecting them to. I just connected them all up. I'll give that a name. That's the left switch on my particular little fancy layout here. And now it's going to actually label the tab that way so you can tell which of these 8 things do what later. It's the left switch. Next thing is down here. Normally things will be either an output or an input. By default, they are an input, not an output. So output is set to no function at all. Input is normally set to active low. Electronically, people, including myself, like to wire things up active low. So 0 or ground activates the thing, and 5 volts or high deactivates the thing. There's a very, very old electronic reason for that, dating way back to the 70s, but it's kind of stuck around. You can wire it the other way if you want, no problem. So I'm going to just leave it that way. This is an input. You notice one of the other things is, when you click on these menus, you'll get all sorts of, alt action, low, alt, what the heck is all this stuff? Yeah, don't worry about it. Disabled, low, or high. Stick to those until you get into the advanced class, no worries. Just ignore everything else. And likewise, output function, not there at all, or active high or active low. When this thing is active, do you want it to produce 5 volts or do you want it to produce 0? Which one is the active or on or going state? Just stick to those 3. Look at all these other things it can do. Yeah, never mind. Just stick 3. You don't need the other ones for very much. There are delays that you can program to make really fancy sorts of things in here. Ignore that too. Here's the important stuff down at the bottom. Each one can produce and consume events. So up here at the top, the little c is to be a little mnemonic for these are consumer things. When you see this event, when this event occurs, blah, do something. Down here, there's 6 more events down at the bottom here, and these are the producer. So this says send this event when this happens. So right here, I've got a switch. I don't want it to consume anything. It's a switch. I want it to produce something. Normally inputs produce things and outputs consume things. You can do it the other way around too. Sometimes there are weird cases where you do it the other way around, but I'm just going to go down to here and say, okay, When the input goes on, and that's the switch is up in my case, you can wire it either way. What I wanted to do is send this event. Oh, hey, look, there's that little 4E I was getting. That's exactly what I was getting by default. I'm not going to do anything with it. I could change that to whatever I want. I could change it to, you know, the stuff at the end to 1, 2, 3, 4 or something if I wanted to, or 0, 1, 2, 3. Doesn't matter, but I won't change it. That you almost always need 2 of these events. You can have up to 6, but in this case, I just want an event saying, hey, the switch went up, or hey, the switch went down. So event 1 and event 2 are going to do that. Notice that event 2 says when the switch gets turned off, the other one said on, this one says off, produce this event. Oh, that's the one ending in 4F. So this one said 4E, that one said 4F. So there, if you want to change them, are the 2 things that happened by default that made that switch do what it did. I'm not going to change them. I'm just going to leave them the way they are. But if you wanted to change them, that's where you would do it. So there's
John, hey, John, this screen is particular to the Railroad Circuits Signal LLC. How did you associate that?
Sort of. I didn't, is the short answer to that. This JMRI Panel Pro, how it works is it sends, and if I disconnected everything and reconnected it again, I could show you doing this. When you first open up this thing, it sends a signal out to that node and says, hey, tell me what all you got. The node ships back something. It's in a format called XML for any computer geeks in the audience. And JMRI uses that to populate this screen that I'm showing you right now. A different event, a different node from a different manufacturer would populate it a different way, but it's all automatic. It's the node that is sending all of this to JMRI, and JMRI is very obediently displaying it for me. But
what happens if you have 10 nodes?
Well, this is per node. I got this by clicking on, let me configure the Cranbrook East Yard node. Okay. And if you have 10 nodes, you bring up a different window like this for each and every one of them. If they're from 10 different manufacturers, tough right at the moment because there aren't 10, they could produce 10 different kinds of displays.
So it does auto detect for every node in the LCC bus?
Yep.
And then you select which one you want to configure.
Yeah, so in my little menu, let me just go back and share that screen for just a second. So in mine here, this is the window that I got when I first opened it up. And I only have 2 nodes on my little baby network. So there only are 2 things here. If I had 10 nodes on my little baby network, I'd have 10 things there. And I just pick which one, like the Cranbrook East Yard here, that I want and say, hey, open the configuration for that one.
Great, thank you.
And I would get it. Right, I think there was another one there somewhere. No? Okay.
I was just making the point, John, that it didn't matter whether you had 1 or 500. It's just going to be an indexed list of all of those at one point because each one's an individual entity.
Yeah. Yeah, so you do this very hierarchically. You say, hey, I want to talk about that node. Once you've got that node, you say, I want to talk about this particular pin connected to that node. And then you've got up to 12 different events that are produced or consumed by that particular pin on that particular node. So you burrow down to the stuff that you need. Okay. Let's go and do a more interesting one where I'm actually going to change something. And I happen to have the first light on my little test layout there hooked up to pin 5. So I will call that the, I don't know, leftmost LED. It's a good name as any for it. And I'll make that change so we can see it up here in the tabs. Okay, this one is an output, controlling an LED. So I do want it to be an output, and I wire my LEDs as active low rather than active high. So 0 will make the light go on and 1 will make the light stay off. And you normally would only have one of these. Normally it'll be an output or it'll be an input, never both. There is in the very advanced class, there is a way to use both at the same time by sort of a time sharing weird thing. I don't really think I would ever use it, and I wouldn't encourage most people to use it. So this one's an output. So say, yes, you're an output. No, you're not an input. Ignore the delay and go down to the events. So this time, I don't want to produce any events. By default, it's still going to do that, actually. So I'm going to go down to the producer events and say, no, you're not going to ever produce anything. So no, no, no. None, 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 none. No. Up here, here's the consumer events. So I'm going to say, watch out for this event. And when you see it, do this. So I'm going to say, okay, turn the light on, line active. Okay, so as soon as it sees this event, it'll turn the light on. Well, I want to use the switch to control the light. So I need the event there that says the switch just went up. Now we can probably remember in this simple situation that it was 4E that said the switch went up. But in real life, you probably don't have that big a memory if you have 500 nodes in your system. So you could do a very simple thing to keep track of this. And that is, you could just make a little text list in a text editor somewhere on the side and just make a little dictionary for yourself. So I've made this. I've made a little dictionary of, here's some events that are in mine and this is what they mean. And you can also get Panel Pro by creating fake turnouts and fake indicators to do that for you. Seems a bit like a kludge to me, but it can be done. And they're making it easier all the time. In fact, this new version, I could show you how the Balash, who is working on this stuff, has actually made it much easier than it was even a week ago to do this. But a simple little text pad will do it just nicely. So, switch 7 up, that was that thing. Cut and paste it into the window. It's not too hard to do. Don't worry about all the little bits and ones and zeros and F's and E's and all that sort of stuff. So I'm just going to go and paste that in here. Paste and write. And now one thing, note I changed this from none to online active. When it's a pull down menu, it doesn't turn it orange. And you have to remember, I haven't written that yet. Down here at the bottom of the screen, there's a Save Changes button. If that thing is lit up, that means you haven't saved something. Just go click that thing frequently. There we go. So when the switch goes up, the light should go on. Let's test it. Let's go over and try it. So let me go over to the real thing here. And when I flip the switch up, the light goes on. Hey, when I flip the switch down, absolutely nothing happens because, of course, I didn't consume that event. Remember, you always have to do two things. When it goes up, do this. When it goes down, do that. Well, I only did half of it. So it'll go on all right, but it'll never come off again. Oh, okay. Well, let's fix that. I will go over and go back to keep making you seasick changing windows all the time here. So I've got light on when I hit 4E. Let's create a second event and say, and by the way, when you get 4F, I'm just going to do it from memory this time. 4F is the switch went down, turn the light off. Okay, switch down, light off. Good, save all those changes. All right, now it should go the way it really should. And we go over to our layout. And 7, it's on, 7 down, it's off. And that's the very, very basics of how this works. There's how you create events that get sent around, produce them, consume them. Everything else is a little bit of that. There are some more complicated things. For example, I can show a thing where you want to do something only if 7 and 8 are up. Or to do a signaling system, you would probably do something that says, okay, if the dispatcher hit the code button and the switch is in the east position, and there's no locomotive on that track, and this other signal is red, and this and this and this, okay, then send out an event that says this. These events can spawn other events, which can spawn other events. So in that sort of situation, you'd probably have this button has been pressed event. that would get checked against something else, which might trigger an, okay, the dispatcher is clearing you eastbound event. That might get combined with something else to say, okay, the dispatcher has cleared you eastbound and the track is unoccupied event. And there might be all sorts of events triggered and flying around. That's the extra thing that I mentioned to you. So I can stop there with the basic overview of what LCC is. It would take about 20 minutes to show you the logic part of it for doing something that requires a little more intelligence. So I'll let you decide whether you want to see that bit or whether you want to call it off there.
John, before you go any further, sir, thank you. That was an excellent presentation. How much money have you got sitting on that picture?
The money sitting on that picture? Well, I'm talking Canadian dollars here. I think the whole lot with cross-border shipping and exchange rate and all of the nasty things that people do to you, it probably came to about $160 or $170, something like that, for the whole lot, not including the homemade little junk at the front.
And
here.
if I were to add another node, how much would that be?
Gee, you know what? I'm gonna say go to RR Circuits, check their website, and check a more basic node than this one. This is probably the most expensive node they sell. A more basic one would probably be called a Tower LCC, and that'll give you an idea in US dollars of what cost of a node would be. It's, this whole thing, if I was on the other side of the border, would have been about half that.
So John, Phil Edholm. So actually you brought up a great discussion, and I don't want to have the discussion now. I'm just going to kind of preface and then suggest what I think the discussion should be. Just 2 seconds of background before we start. You'll find I'm one of the authors of all the original Ethernet standards. And one of the 4 laws of technology is the law of bandwidth is actually named after me. I'm a networking guy. So my assumption is that the idea of writing a program by going and programming events is going to give you a fairly simplistic, I'll call it control scheme. Doesn't this generally interface up to the panel pro control schemes that are in the CTC panels and JMRI generally if you want to run a railroad?
You could run this LCC network through JMRI and Panel Pro and all of its.
So I guess what I'm saying is, if I look at that, there are a bunch of schemes up there where you can kind of define layouts and topologies, and you can have a control panel, and you can have all that control. If you do it yourself just with events, you have to recreate all that, or you interface this up to that logic that they've built. That's what I'm trying to understand. Does that make sense?
If you wanted, as I said, to take the computer and unplug it and throw it away and just have the LCC layout running autonomously without a computer hooked up to it, it would be a fair bit of work. You would have to, understand exactly how the signaling system works, exactly how you want your rules for clearances and things to work, and so on and so on and so on. And it would be a fair bit of work to set it up in a nice customized way for exactly how you want it to work. You could just as easily hook it up with the computer there full time. JMRI as one of the nodes on your
Jim, can I share my screen? Can I jump in and share my screen? Because I want to show you the question.
That would be required for me to do that.
Okay, never mind. So I'll just explain what I'm saying. So if the application is JMRI, the Panel Pro CTC application, basically there are 2 ways of implementing that physically within your railroad. One way is what was defined in CMRI with the Chubb system or Seth's CP nodes, but it's basically a system that has what I'm going to call more centralized aggregation of data. What LCC has proposed is that wiring is a problem, and therefore the right answer is to distribute intelligence.
Well, not necessarily distributing intelligence. The LCC network can act exactly like CMRI, and it can look.
I understand it can, but here's the difference. The difference is it's a fundamental difference. If I have a protocol bus and I put nodes at the edge, they have intelligence and have to think on their own. They're not dead simple wires that can't fail. And if one of them fails, can it bring the bus down? All sorts of interesting questions. The alternative is to use really cheap wiring to aggregate the intelligence in central locations as CMRI did. And it's a really interesting, and by the way, the reason this is so interesting is not because it's a model railroad discussion, because in fact, it's a fundamental technology discussion, information technology about where do you push intelligence. And by the way, I will tell you that if you look at the world we all live in, we all pushed intelligence out to the edge back in the early 80s and into the early 90s. Because we built PCs that were very intelligent and they had operated autonomously. The World Wide Web is a reaggregation into the core where the intelligence is centralized and the edges have become relatively simple. Yeah. And so, but now I'll bring to the points. If you look at it in terms of reliability, availability, dependability, maintainability, and cost per served endpoint. So for example, if I define a 2-target searchlight signal as needing to have 6 IO points to support it, what's the cost of implementation? So by the way, I'm leading to something that I think is an interesting discussion. Who would be the right person, and maybe yourself, to participate in basically a real discussion around that at the NMRA in July? Because I think it's a really interesting, because I will tell you, we're doing a layout in California, and we're going just the opposite.
Okay.
We have Cat5s running. So if you have a signal remotely, basically the signal base has 2 RJ14s to go to the signal tower. It's got a Cat5 plug that you plug to run back to the panel. And all the wiring is going to be star-based Cat5 wiring with the intelligence very centralized, because it makes it a lot easier to manage all the maintenance and that down the road. Because I know if I can sit on at one point, I can look at the wires. And if I know that wire's got positive, I know it's positive at the light that's 15 feet away or 30 feet away. And so I think it'd just be a really interesting debate. And by the way, I actually don't have a personal, I love the technology that you guys have done, but I'm just wondering for the average model railroader, does the distribution of intelligence in a bus straight structure, maintaining it and doing that, and the cost of that distribution make it not the best option except for certain situations? And that's kind of I think the dialogue we should have as a community to make sure, because I don't think the railroad community is being well served by not having it kind of brought what the options are and what the differences are. Mm-hmm. Anyway, enough said, and we can get together after this, but.
What you probably want to do is go on to the 2 groups IO sites that are doing this thing. One is OpenLCB. So OpenLCB is a group of people out there who are developing all this stuff and who are working on the answers to all those questions and have decided on all those questions. So it's called OpenLCB is the name of the group. It's on Groups.io. And then there's another one called Layout Command Control. That's for the users end of things. So the OpenLCB is the developers end of things. The Layout Command Control is the users end of things. And then of course there will be people at the next NMRA National Convention, if we ever have a next national NMRA.
We are having one. We're having one in July.
And all those guys will be there. And
well, we're going to have one, and we're going to have a convention in July.
An online one. Yeah, I was just speaking.
There'll probably be more people at that. But by the way, just aside, we're actually doing one in 2 weeks, the PCR, which we're using the same tool set for a week and a half that we're using for the national convention. And we'll be able to have a really interesting dialogue on this at the national convention. So what I'm trying to do is not just go out and push something on a post. I'm looking for, who are the folks who really are the champions of and the evangelists for believing that this is the way you should build a railroad. Because I actually tell you, I think I've got a really good champion that centralization makes a lot more sense.
Well, that's the group. That's the group you want to talk to. Groups.io and OpenLCB.
Cool.
All right, should I continue with something else, or is that a good enough overview for people?
I have a question, actually 2. if I can remember the second one. Well, our circuits
Right.
is one manufacturer. What are the other manufacturers that are there? You mentioned there's less than 10.
Yeah. Oh no, there's far less than 10. Unfortunately, that's one of the problems. Is that this was started 10 years ago, and it was slow to get off the mark, and a lot of manufacturers went off in different directions. Now it's starting to get a little more traction. The other big one would now be TCS. They are manufacturing a throttle that speaks LCB, open LCB, and they will be having also a command station which will do both DCC and LCC at the same time, controlled by that wireless throttle. So TCS is starting to jump into LCC. They're the other big one. None of the other, what I would call big manufacturers, are participating in LCC yet. There are a list of, oh gee, I don't know, a dozen or so other smaller ones. I don't have the list offhand, but I could, of course, get it for you.
All right, thank you. The second question was, from what I understand, LCC is layout command control. What is LCB? I never heard of that one.
Oh, OpenLC. Let me maybe give the political background here. So about 10 years ago, the NMRA decided they wanted something to control layouts like this. And they said, okay, give us your proposals. And there were a set of proposals made by various people. And one of them was OpenLCB, and they are a group based on the internet. They're a group of very technologically savvy people that got together and produced this standard based on events and this and that. And they were chosen by the NMRA to say, okay, you guys develop these standards. So OpenLCB is the group, and the LCB in there stands for Layout Control Bus, I think. And they develop these things, and we have a new agreement with them and the NMRA as of just a few months ago. I'm on the NMRA board as well. And so they would create their standard, they would ship it over to the NMRA would look at it and say, yeah, that looks good, or oh, you should tweak this, you know, didn't you make a mistake here? And then they would maybe tweak it. They would send it to the NMRA would say, right, good, stamp of approval, that goes up as an NMRA standard now, and away we go. So there are so far 9 different parts to the standard, I think it is, that are up on the NMRA website. And there are a few more getting very close in the pipeline. There's going to be a standard for how this thing controls fast clocks, for example. That's one thing that they've been working on quite hard.
All right,
John,
thank you.
What's the difference between LCC and LCB?
LCC, OpenLCB, there is no LCB. Okay. OpenLCB, taken all together, is a big word. They're the people who are developing the LCC standards.
So they're not separate. They're the computer geeks that are putting all of the details down.
Exactly right. Yes.
Gotcha.
They are computer geeks to a man. Yes.
Now let me ask another dumb question. I'm a model railroader.
Oh yes, they're model railroaders. Yeah, some of them are very good model railroaders.
No. I say I am a model railroader.
Oh, okay.
And I'm trying to figure out why should I use LCC? Yeah, I've got wires going all over and everything else. Why should I take any of that down and convert it to something like this?
My short answer would be I wouldn't. If you've got a whole lot of things already built with a whole lot of wires in it, I'm not sure that conversion is a thing that you ought to be thinking about. It's more of, if I was starting now and building a layout and it was going to be fully signaled and have all sorts of toys in it, I would start it off now with LCC. I wouldn't probably, take some huge layout and retrofit it for LCC. That would be a rather large amount of work.
Let me ask you this: when you start talking about the toys for the layout, my new layout, my new layout would be fairly small. It wouldn't be gigantic. It might be a 5 by 9 foot or 4 by 8 foot sheet of plywood. Why would I use this rather than wire it like I've historically done all my other layouts?
A very small layout, 4 by 8 sheet of plywood or something like that, it's probably not necessary to use LCC. LCC comes into its own when there's quite a lot going on, and you know, particularly I think more or less the dividing line for sure is signals. As soon as you get into that, it's inherently complicated to do that, and that would certainly tip the favor over into something like LCC. If you've just got, you know, a few block detectors lighting up a few lights on a fascia somewhere, there's not a lot of need for something complicated for that.
So really, then LCC really is poised for the, I guess the large individual layout or the club layout.
Well, that's certainly one thing. Or, you know, I have a layout where I'm going to be expanding it from one half of the room to the other half of the room, and it's got signals on it, and I will probably use LCC for the other half of the room, for the new half of the room. And this is in a spare bedroom. So
can I make another suggestion, Jim?
Just be complicated enough to need it.
Can I make another suggestion of an area that this actually would be absolutely interesting? Would be any modular group that's doing any sort of mainline railroading where they actually want to have some sort of overlaying control system, because you literally could have plugs on each of them, the modules, and plug them together. The LCC, you could have an LCC node on each module, and the chain of those would actually give you something that if you were really fast, you could actually potentially build a signaling scheme on the fly for a specific layout configuration. I mean, it's a really, the modularity actually there really makes, because there the nodal intelligence stays with something like a module, and it makes a lot, you know, and really, by the way, what I'm talking about here is how centralized you want to do things versus how distributed. And I think the challenge is everybody's looked at LCC as you distribute it way out. Other way to think about it is, might be really interesting to think about a more aggregated LCC node, which would actually do the same thing I was talking about. It just makes it a lot easier for kind of smaller things to get started, as everything's in one place just to get going.
Yeah.
Anyway, interesting thought.
They're working towards that sort of thing with a protocol. By the way, there's a whole lot of other stuff that is flying around besides your events on that LCC bus. You know, for example, when I said, hey, I want to configure this node, the first thing that happened was it sent a query down to the node saying, hey, node, tell me everything that you've got. And it sent a huge amount of stuff back. I didn't show you any of that stuff, but there are things like that. There are global commands and so on. And one thing they're working on is something where a node could query the node next door and say, hey, what are you and how are you configured? And so the nodes can talk to each other in a system, something like a modular layout, and negotiate between the nodes as to what's going on.
Right.
That is really, really tough to do.
Well, actually,
but it is being worked on.
It's actually interesting to think about. They don't need to negotiate what's being done. If you could just take the positional analysis that you would get from that, you could now have this concept of tiling, and you can create the layout and tiling to feed up to the CTC. And if you got the rules above and you automatically can create the layout by tiling, you now can make a self-configuring layout. And that's the big problem with JRMI, is that connection of kind of the configuration of stuff up, that if you change it, it becomes a major. Anyway, interesting.
Yeah, you might want to talk to an LCB guys too.
No, it's like I said, the conversation earlier was really a philosophical thing of where you put intelligence. I think there's some really interesting things within LCC when you make it a bus versus kind of the way the difference is the CMRI is a highly hierarchical structure. You've got the computer, it talks to 2 or 3 nodes. The nodes actually don't have any concept that anything else in the world other than them exists. And their only relationship logically is to the computer system. So everything flows through. You've actually got this other that allows you to do some fairly interesting things locally in addition. It would be interesting to think about how you could exploit that. That's very interesting. Thanks.
John, could I go back a couple of baby steps here?
Sure.
If I have a medium-sized home layout and I have everything operational using DCC, and I have just started to add block detection where I've got most of my blocks identified, but I haven't started the signal system yet. Would it make sense as I start to go adding signals to go to LCC, because doesn't that stand separately from my DCC system, so I don't have to add anything more to that?
Oh, absolutely. LCC stands completely separate from your DCC system. To operate in parallel with it. So DCC, that's still there. It's still exactly the same as before. It controls the locomotives, the track, all that stuff. The LCC system is in parallel with that, and that's what your block detectors and your signals.
Okay, that's encouraging. It took me 10 years to get the DCC up and running a satisfactory mode. I'm not too computer savvy. So the ability to add on without messing up what I've already got has a lot of appeal.
Yeah, no,
I found myself in exactly that position where I've recently added signals to an existing layout. And it was a challenge. What you wind up with is a real tangle of wires.
Yeah.
I think LCC is a really good alternative to that situation.
Yeah. It would prevent the sort of underside of a layout that I showed you earlier, which is
yes. I'm very familiar with that.
But
I think you also get this creeping complexity. You start simple. I'll just hook 2 wires to the track. That's all I'm going to do. And it goes from there. Yeah. And if you think ahead, if you plan ahead, then putting a system like this in makes a lot of sense.
But I think that's where you have to differentiate. DCC is for running the train.
Right.
LCB or LCC, whatever you want to call it, is the everything else bus line.
Right. Well, Clark, if you're modeling modern stuff, which an awful lot of new people are doing.
Yes.
What railroad's not signaled?
Yes, exactly.
Come on,
Yep. That's why I used to model narrow gauge.
There's a smart guy there.
But I'm on this new layout. That's exactly why I'm looking at going this route, and I'm just sort of dabbling, looking at it myself. But on the other hand, I'm also looking at just doing a real simple Arduino setup, and I'd be done because I don't need that many. I don't need that many blocks. So
let me chip in a thought. I use Arduinos. It's complicated.
Yeah.
By the time you run all the wires from all the locations, you wind up with an awful lot of wire.
Well, that is the downfall to that. There's no question.
Well, how about this as a hybrid? So one of the things being worked on is a dev kit, as they call it, LCC node, which is an Arduino or something similar. So how about taking an Arduino, plunking it in as an LCC node so it can see all of the events and send events itself, and then you program it locally to do whatever you want in your area. And now you're not using the sort of stuff that I was going to tell you of how you put the intelligence in an LCC node. But now you know, if you're a programmer, as I am, hey, I can just write a program to do this.
Yeah.
You know, I'm off and running now. Now that would be great. So you essentially have an LCC network where the nodes are Arduinos. Yeah. Now there's my gold standard right there.
So again, John, I think come back to that. It's an interesting point. So again, you got to stop and think about it. Using an Arduino, and that's a great concept, as an LCC node. You can now have a fairly large LCC node, so you could have a single LCC node for your layout. The logic is going to be up in NMRA, in Panel Pro. If you want to have a more complicated signaling system, probably, because you probably don't want to try to write the signaling system at the event level. You're probably going to want to use what's there.
Well, I'm crazy, so I'd probably do it at the event level.
I would assume the majority of model railroaders would not be able to think through, what has to happen to do an interlock.
Yeah,
and
correct.
And those kind of things. So I guess, you kind of think through, there's probably a couple of layers of question here. One question is, do you commit to JMRI, or do you use there are a couple of commercial alternatives? And I think that's probably a first interesting question for people to think about when they look at it. I'm coming back to the question Jim asked. So I've got a railroad. I want to signal it. I'm going to put in 40 signals. When I look at how to program the railroad, there are some other options. And by the way, I'm not advocating anything, but I've had a couple of people recently tell me they looked at JMRI and other things and made an alternative decision because they said the level of effort to set up a railroad so you can control it from a computer was dramatically lower. So that's kind of a first question. I think if you decide you're going to use JMRI, which I think is I think it's a good decision for a real active model railroader, because you can get signaling schemes and many things. The concept of an Arduino as an IO point, is basically a great concept. If you do that using this protocol, you can now implement other things later if you want, but you can use the protocol up above. But you can now have that concentration. So I think you kind of get the best of all worlds. But everybody who's complained about wiring, I want you to think about this. How much is a spool of Cat5 wire cost?
Yeah.
1,000-foot spool of Cat5 wire. You can get them online. I don't think they're $100. They're pretty cheap. So how many wires to endpoint devices are there in an LCC network versus a CMRI network? Is there a difference?
They're the same number of wires pretty much,
right, okay.
But they're shorter.
Exactly. So my whole point is, the reason you locate the nodes out is because the wiring is a mess. But if where you put the nodes, you put a Cat5 cable and you run it back 30 feet, 20 feet, and then you plug it in. There are these 48 port patch panels that you can plug 48 Cat5s in the front, and in the back you get punch downs, and you can punch those down over into the Arduino. You've now concentrated the Arduino in one place. And so I'm telling you, is the reason wiring is a problem is you didn't structure it. If we take the wiring components from the telecom world, all that stuff that lets you do Ethernet so dang easily, and we bring those wires over into our world to wire, yes, you have a wire running 30 feet, but it's a Cat5 cable and it's labeled at both ends, and it doesn't look like what you guys have seen underneath your layouts. It looks very different. And I think that's kind of the question. My concern is you distribute this bus around the room. When something happens to it, how do you troubleshoot it? How do you find it? How does the average model railroader deal with it? Versus use the protocols, but concentrate things more and kind of don't push things out so far. I think it's going to make it harder and harder for people to troubleshoot. Plus, when you have a light problem, you're down under the layout versus sitting at a stool in front of it. So that's, I think, the Arduino is the ideal answer here, because you can build very inexpensively a bunch of IO points at a single location with an Arduino. So if you can get an Arduino sketch for an LCC interface and open up the door, I think that would cause, seriously, if we had that would cause a huge amount of adoption.
I believe that Balash has written one of those and it's out there, but it's a very, shall we say, hacker hobbyist sort of level. You have to be pretty good at, putting together that sort of stuff to do it. It's not something that if you're not comfortable with that sort of electronics and
I can actually answer that. I can actually answer that because I got involved in discussions with the OpenLCB group about using Arduinos, and most of the current crop of readily accessible Arduinos are underpowered for a node operation with LCC. Now, there are, since that time that we had that discussion, there are newer models that are compatible with the Arduino development that are much faster, much more capable, much more memory.
Right.
So that can change, obviously.
Right. Is it the supporting the CAN bus that's the problem with the slower?
It's not just the CAN bus, it's the whole protocol together with the anticipated configuration stuff that John's been going through. It just gobbles up everything that the Arduino's got. So you need to look for something bigger and better, which there are.
What kind of processor do they run on an LCC card? That
I mean, if I had better eyesight, I'd tell you right now, but I can't.
I mean, if what you're telling me is that you need such a super processor beyond the power of an Arduino I/O device to run it, the LCC nodes must have supercomputers on them.
No, they don't. But remember that the Atmel processors that are on most of the Arduinos commonly available are pretty long in the tooth right now. So there are other processors that are readily available that are a little more expensive. And there are also wireless nodes that are coming out now as well that have a lot more compute power. John, I'd like to ask you a question in kind of a different vein from a user standpoint. And that is, in a former lifetime, we used to have a concept.
Oops, sorry, I got muted there, Jeff.
I got muted. I muted you accidentally, Jeff.
I'll unmute. In a former lifetime, we used to ask a series of questions about new products and new applications. And one was, what's the killer app for the application? So I'm going to invert the question and ask you, if I eliminate signaling as a model railroader, is there a killer application that this really lends itself to that's not signaling?
Not signaling.
I've got an answer for that.
Sure, go ahead.
Route controls for turnouts. Single button to select a yard track that may align up to 5 or 6 turnouts.
You don't need the capability for LCC to pull that off.
Well, that LCC would be a way that a average model railroader could do it plug and play.
Actually,
I don't think there's anything on the market that will do that.
It really is an ancillary function of LCC. It's one of the many things you can do with it. I mean, I've put some comments in the chat, and I think LCC is the bomb. I've got a railroad I'm building that's industrial districts. It's 6 industrial districts on each deck. And for each one, I've got a signal LCC, what's called a Bob, that's a little breakout board, and a BOD4CP, which is their occupancy board, and it runs switches. I've got one of those at each end of the industrial district. They're tied together with a Cat5 cable. I have touch switches from Barrett Hill on the fascia. And I also tested momentary push buttons. I have model railroad control systems, MP1 switches. I like them because they're only 1 inch thick and they can embed right next to the turnout. And you know, I can update when an update comes out. I can flash that update to all the nodes at once. Once it's programmed, you don't have to have it hooked to a computer. However, I did have it hooked to a panel, or I do have it hooked to a panel in JMRI. And so the dispatcher can control the turnouts, can see the signal, can see the occupancy, all of that. And you know, I've got 35 plus years in IT behind me, but I don't think my experience in IT helped me much here. I was on the phone to Dick Bronson a whole bunch of times while I was, you know, getting my nose bloody doing this. But I've got a sample here of what my little LCC mounting boards look like. And you can see the signal LCC, the breakout board, and the occupancy detection board here. And I labeled all of mine because frankly, I forget things, but you know, it's really easy. I've got the labels on here that tells me where the detection wires go and where the signal wires go and what order of color they go. I could give this to one of you guys and share the CDI The control screens that you were showing, John, those aren't embedded in JMRI. JMRI is a window into the CDI, which is embedded in the LCC, the signal LCC. Okay.
So Dan or John, what's the big advantage that either of you have seen in using LCC compared to anything else you've used before?
Well, for me, I don't want to program anything. I retired, and I don't want to do any of that kind of stuff anymore. To be able to go into the CDI and select things in a drop-down menu, and when you write them, you can look at the boards because the lights will flash on the boards to tell you that it's working. So what I did is, this is my train room here, and to the right of me is an 8-foot table. I had all my LCC nodes set up, daisy chained with 1-foot cables. You know, they must be at least 1 foot. And I could see the lights flash on it as I wrote things to the boards. And I just think it's so straightforward. You know, you're going to have to go through a lot of pain because I think, John, your presentation is probably one of the better ones I've seen on how to make all this stuff work together. But like I say, you get your nose bloody in the beginning, but once the light bulb comes on and you have an aha moment, then you go, oh, well, that's how it works. And then it's easy after that.
Let me ask you a question, if you don't mind, right there. What do you mean about at first you're going to get your nose bloody? What the average guy, the average model railroader says, okay, I'm going to jump in this.
Right. Well, when I got interested in this, in our division, nobody else, our NMRA division, no one else had touched LCC. So I was kind of the only guy doing it. I think I still am. But, you know, just trying to find the resources, you know, looking on the JMRI website, that didn't help me understand what was going on at all. A couple of guys have written books that are available on Amazon, and that helped me a little bit, but not a lot. Yeah. You know, I think it's just, you know, buying the equipment. I bought the starter set, and you know, NMRA members get end column pricing from railroad circuits, so we get a better price than normal. And it's just going through how to set up, understanding the concept behind it. Oh, there's a CDI that you've got to get into through JMRI. That's what that is. It's not really in JMRI. It's on the boards. You're looking at the configuration table on the board. And just things like that. I don't think it's as straightforward as it could be. But, you know, God bless the guys that are programming. That's not to take anything away from them. But I really hope that at some point this becomes a GUI interface and there's some kind of wiki or something that says, hey, I've got some industrial districts and I want to signal the siding, 2 approaches and the main through those districts. I want to have a fascia mounted button, whether it's one of the fancy touch toggles or touch triggers rather from Barrett Hill, or if it's a simple momentary push button. That's how I want to run my signaling. And oh, by the way, I want JMRI to be able to run this stuff too, and control it. So if somebody locally calls the dispatcher and says, "Hey, I need to throw this switch because I've got a train waiting and I've got a train that needs to get into the siding," the dispatcher can say, "I'm going to throw that switch for you," or "Go ahead and throw it because I can see it when you do it." And nice thing about the touch toggles is they turn red and green when you do that. And I can't say enough about the MP1 switches. I mean, it's like 1 inch square and a 1/2 inch thick, and nestles right down in 1 inch foam right next to the turnout. Yep. You don't have to get underneath to wire anything. And I use WAGO connectors under my railroad, so I don't solder anything except the feeders, of course.
Dan, I'm going to jump in here, and I think to Jim's point too. I spent a lot of time with the boys from TCS and know John and John very well, and and the boys from Europe, I think it was 2 conventions ago, basically I sat with them and they're working on their computers. They're all working together. If you go back to what DCC started as, and you had to actually have a plug to plug in to decide that was going to talk to that engine, and look at where we've come in DCC from 10 years, say. We have basically got plug and play. Stuff knows that it's there automatically. And you're going to see that with LCC. It's just going to be a matter of a little bit of time, but as these guys work through it. And I think you're going to see more and more manufacturers get on board because they're going to see the commercial value of it. So for those of us who are not computer geeks and are kind of sitting on the edge, I think within 2 or 3 years, it's going to be just like DCC is today, where you're going to go, oh, here's a sound module, I'm plugging it in, and I push F8 and I get the sound on, and that's going to be what's going to happen with LCC. I can see it coming on. These guys are, the volunteers that are behind this and working on it are unbelievably, and they're all young guys. Jim, you asked earlier about who would do this. Well, I got news for you. If you want young guys in the hobby, like Dan, he's a young guy.
I'm 67, by the way.
Well, I'm a little older, but not much. But those are the guys that you're gonna bring in, those younger guys, because the secondary hobby isn't necessarily the trains; it's the electronics.
Yeah, in a lot of cases. That's what really spurred me to do this. Is I love electronic stuff. Yeah. And so,
anyway. I think going back to this, I think the perspective here is that the LCC has been positioned as this thing that you distribute, and I think that's really not necessarily true. And that kind of is said people don't look at it for smaller layouts. I think if you had a way of doing a real small startup that was a little more detailed, it might be a lot better way to get people to adopt it, because the protocol, the back-end event protocol, probably has a very different value over time than what you get in JRMI with kind of the full panel pro control of a layout.
Yeah, I agree, Phil, but I really think they're simplifying it, and it's gonna happen.
Guys, I hate to do this, but it's getting on to be 9:20, I think. And John, I would love to continue this. I'd love to see your other video and everything. I'd love to invite you back.
Sure, go ahead. That would be fine. Yeah.
But I think we need to cut this off tonight. And I know I've got to go to bed. It's past my bedtime. So I hate to do this, guys, but I'm going to have to stop it tonight. And John, thank you so very much for doing this. You really shed a lot of light on it. And I really do appreciate so much you coming tonight. And I will get in touch with you and ask you back to talk about this some more.
Okay, thank you very much. No problem.
Thank you so much. Well, gentlemen.